And let's get things started then. So good morning, everyone. According to this badge, my name is Mark Murphy. Don't believe everything you read, unless it's expert Android device from somebody claiming to be Mark Murphy, because that stuff is totally credible. You may have heard of me from such things, if I can find my mouse again, as my book, The Busy Coder's Guide to Android Development, or 15,580 answers at present out on Stack Overflow in the Android tag, including one comment that I obviously need to address at some point. So, and my job here today is to talk to you about Android 6.0. It's coming. They're down on the mall carrying the signs, the M is near, and that it is going to be possibly as early as late this month, and that when the new Nexuses will start shipping, and usually at that point in time the OTA updates appear, and that for all of the subset now of the existing Nexus devices that will be getting Android 6. Now, many of you have been around the block with Android before. You know how this works. For the next few months, this is going to be rounding error in terms of how many people that have Android 6.0, and that it's not going to get to the double-digit percentages until sometime in 2016. But that rounding error tends to be a bit of a noisy rounding error, and that it tends to be a lot of power users, fellow developers and the like, and that who are going to be trying your app on 6, and they're going to be expecting 6-level behavior. And in particular, they're going to want to be taking advantage of certain of the changes that are coming in 6. And so there are certain things that you're going to need to think about. As with every of the major releases, Android 6 is vast. I'm not going to be attempting to cover it all here today. And now what I am going to be focusing on are the things that you should be thinking about now, with an eye towards 6 being released to production here in the coming weeks. Some of these things you're going to be needing to think about more immediately. You're going to be needing to think a little bit about the runtime permission system, because the way we deal with permissions is changing significantly. Even if you think, oh, well, gee, nah, my old app will work just fine. It may work just fine, but you're still going to need to think through some of the ramifications, even if you try to get away without changing anything. If you do want to change things in that, you'll have a little work to do. We'll talk about the war on background processing, how Google is trying to stretch battery life, and that with some attendant costs for us as developers in terms of the ways that we're able to get control in the background to do periodic work. Talk a little bit about changes in backups, talk a little bit about adoptable removable storage, all things that are stuff that you need to think about in the here and now as we're ramping up to 6. Also talk a little bit about a few things that maybe you'll need to think about. That first bullet of the list, most apps are going to need to address to some degree. But if you're implementing action send, and that you'll need to think about direct share targets. If you're handling things where you've got intent filters, where you are advertising that you support certain URLs, and that HTTP, HTTPS, you may want to think about app links. And for those of you who are still using Apache HTTP client, there's some bad news. And that they will have to talk a little bit about how to deal with that as well. If you have questions, I will try to take them along the way, but please wave frantically, and that try not to hit the person next to you, otherwise make sure that I see you, and that so that we can try to get your questions answered. One theme with Android 6 is the continuing march as to how Android and iOS are consolidating in terms of feature sets. In the beginning, there were some significant differences between the two, and over the years, iOS has adopted a few Androidisms, and Android's adopted a few iOS things. And one of the bigger ones comes in the way the permissions work. In the beginning, we would have users permission elements in our manifest saying, oh, we need internet, we need write external storage, we need access find location, and things like that. The user gets presented with a list at install time, and over the years, that list has been pared back a little bit. They're no longer pointing out that the apps need internet permission because so many of them do and so on. But then the user would have exactly two choices. Yay, I'm going to install the app and you can do everything, or no, I'm not going to install the app. But with Android 6, the dangerous permissions, those with a protection level of dangerous, are now going to be handled somewhat differently. If your target SDK version is below 23, from a programming standpoint, there's no immediate change. And that your apps will continue to install the same way they've always installed. The user will be prompted at install time saying, hey, this app wants to be able to do this, that, and these. But the user's going to be able to go in and change things. They're going to be able to go into settings, into the apps, find your application here in settings, and click on a permissions entry where all of the permission groups associated with dangerous level permissions are going to be listed that you're requesting, and the user can toggle a switch to say, no, I don't want that app to have that capability. Now, they'll be warned. Wait, this app was written for a bygone era of like 3 weeks ago. And that when, they assume that they're going to be able to do whatever it is that you're trying to toggle off. But the user, if they were willing to go to this level of finding this screen and tapping this entry and clicking that switch, they're probably going to go ahead and click deny anyway. And your app will not be able to, in this case, work with external storage, even though your app was expecting that it could. Now, those of you who've been doing Android development for a few years, you may remember the term AppOps. This was a bit of tech that got leaked, so to speak, in Android 4.3 and early editions of Android 4.4, a hidden screen in the settings app that would allow users to do pretty much exactly what the switches were doing, of retracting certain capabilities from certain apps. And that AppOps is basically what's going on under the covers here. And so your application, if the user goes in and elects to deny you certain permissions, capabilities, you're going to get fake data. Oh gosh, we just don't happen to have any external storage. You can't write to it. Oh gee, you wanted a GPS fix? We can't seem to get a fix. We're in a parking garage or something. You're querying for the user's contacts? This user doesn't have any friends. And that all of which are perfectly plausible. And that your app should be dealing with the fact that, oh, okay, maybe when I query for contacts, I get an empty result set. When I try to get GPS fixes, that it may take a while and it may never occur due to environmental conditions. And so those are all things that in theory you should be handling. Right external storage being upgraded to dangerous in Android 6.0 is probably the biggest one, because those of you who've left Android 1.x and 2.x in your rearview mirror, and that are probably assuming that external storage is always available, because usually on Android 4.x and 5.x devices it is always available, but now it's not. You're going to have to go back to making sure that, yes, you can really work with external storage before you go trying and doing your disk I/O with it. But as soon as you switch your target SDK version to be 23 or higher, you're not only going to need to request those dangerous permissions via uses permissions elements in the manifest, but you're also going to need to ask the user at runtime, hey, can I do this? Some of those you might ask for at first run of your app. Others you may tie to particular events. The user taps on some action bar item or a nav drawer entry or whatever that's triggering a need for you to have some additional permission you haven't asked for before. Maybe at that point in time, you then ask the user. What the user is going to wind up seeing is something more like this. That they're going to be presented with a dialog box where the user will be presented with descriptions of the capabilities that you want to do. In this case, we're saying, oh, we want this particular app to be able to take pictures. Do I want to allow that? Do I want to deny that? Do we want to allow this app to write to external storage? Do I want to allow that? Do I want to deny that? and the user can go in and click allow or deny as they see fit. In this case, I denied the first one, and maybe I'll go ahead and allow that second one. Now, for that second one, right, external storage, I've got that permission. I don't have to necessarily ask for that again. I'm going to be able to go off and work with external storage, at least until the point in time when the user does go into that settings screen and flip the switch to say, no, I don't want that app to have external storage rights anymore. But in this case, I didn't get the camera permission. I asked for it, the user denied it. And so if I try to go take the permission, take a picture, I've got to let the user know, hey, we asked for permission to do that before, and you didn't do it, didn't give it to us. We're going to ask again. Not only do we get the same sort of a dialog box, but now we also get a checkbox. Never ask again. And if the user checks that checkbox and clicks deny, any future attempts that you make to get that permission, dialog does not show up, and you don't get it. The only way that you're ever going to get that permission is if the user goes over to settings and flips the switch in the other direction. And so we've got 4 states. We've never asked for the permission before. By definition, we don't got it. Maybe we asked for it before, and the user said, yes, you can have the permission that you're asking for. The cherubim and seraphim sing hallelujah, and you're going to be able to go off and do whatever that permission allowed you to do. Or we got the dialogue the first time, the user said deny, I'm not going to allow that. Or they accepted it and then changed their mind later on and went to settings and denied it. Or they click deny along with that never ask again checkbox to say no and stop bothering me. We're going to need to be able to deal with all of these. You've got to be able to gracefully degrade in the cases where the user says, sorry, I do not want to give you these capabilities. Some of these capabilities will be important, and that your app will not be able to function if the user does not give those to you. You're going to need to figure out how to handle the messaging to say, sorry, you installed this app. You don't want to give us the permissions to do the things the app needs to do. Could you make up your mind? And some, it may be more of that, okay, well, they say they didn't want this capability, but that's a little fringe feature of our app. 95% of the app is still functional. Maybe you just disable that action bar item and that, or otherwise, you'll let the user know that if they go down that path saying, sorry, you said we couldn't do it before, and now you're, and now you're more or less locked out unless you're going to go into settings and change it. From a coding standpoint, there'll be 3 key methods that you're going to be dealing with. Check self-permission. You'll be able to find out, do you hold a particular permission? You would think that this returns a Boolean. That would be too easy. If you do not hold the permission, you can call request permissions, give it a string array of permissions you want, along with a request code, much like the one you'd pass to start activity for result. And say, I want to have these permissions. That triggers that dialog to appear, and the user will be able to walk through those and allow or deny as the user sees fit. Where then, when the user completes that process, you'll be called back in your activity with onRequest permissions result. You're handed the result code that you provided to request permissions, plus the results. What did you get? What did you not get? So you can make an informed decision upon whether or not you can go ahead and do the thing that the user asked for. And there is the wordily named should show request permission rationale. That's really for that third state. The user denied it before, but it's still possible that you could get it again with another request permissions call. But you might want to then try to educate the user. Before you pop that dialog again, since they denied it before, you may wish to do something, your own dialogue, a snack bar, something inline in your UI, bring up a welcomes kind of screen again to remind the user this is why we need the permission, whatever, so that it increases the odds that they'll go in and click allow when you do eventually call request permissions again. For those of you with interest in this area, after this presentation, I'm going to be running a code lab where we're going to walk through that sample application that I was just in. We're going to have a starting app. We're going to spend some time adding in the code in order to be able to go in and request the runtime permissions, see what we get, react accordingly. That will be in the code lab room right through that partition, though it'd be easier if you go through the door and walk over and go in the door to the other room. And AOL is not going to like it if there's a human-shaped hole put in their partition, and so if you could use the door, that'd be great. Now, there's other wrinkles that have gone on with the permissions as well. They pruned a lot of permissions that had been in the SDK for historical and in some cases hysterical reasons. The brick permission is no longer in the Android SDK. Not that you could ever hold it, and I went looking once and I couldn't figure out what that actually defended anyway. The one that seems to be the most commonly used out of the list that was removed is use credentials, and frankly, I do not know what the exact replacement of that is, but there is a list of 20-odd permissions that have been removed. Probably you're not using them. Use credentials is one of the ones you might. If you've been requesting write settings to be able to go in and try to modify the values in settings.system, or you've been requesting system alert window for Facebook-style chat heads or similar sorts of pop-up UIs, you've got a little bit more work. It's reminiscent of the runtime permission system, but a slightly different engine. It is still a double opt-in. The user not only is going to have to install your app, but they're going to have to go into settings, into apps, click the mysterious gear icon, and then go in to screens to say, oh, I am willing to allow you to draw over other apps, or I am willing to allow you to go in and modify system settings. And the user can go in and retract those capabilities at a later point. A flow more reminiscent of installing a device administrator, an input method editor, notification listener, accessibility service, those sorts of double opt-in scenarios. And so if you're using either of those permissions, there's going to be methods on the settings class where you can see whether or not the user is opted in to allow you to have those capabilities, and if not, there are intent actions that you can use to go drive the user to those screens or in the settings app to be able to go in and tap on your entry and say, yes, I'm willing to allow that app to have those capabilities. Next problem, background processing. Once again, things have shifted as Android and iOS start to more closely resemble each other. In the beginning, the iPhone, you could do squat from a background processing standpoint. You were either in the foreground or you weren't really running. And then over the years, they opened things up to provide more capabilities for you to do stuff in the background. Android said, oh, you can do whatever you want. Background processing, we're into multitasking. This is great because we know that all Android developers are going to be taking into account not only their own needs, but the entire user base and the entire Android ecosystem, and they won't be abusing this and that consuming too much CPU time and whatnot in the background. It didn't work out that way, and Google over the years has been trying to rein that in. Android 4.4, they switched Alarm Manager around to give you a strong nudge to please use inexact alarms, and so they can move them around to coalesce schedules, wake up the device fewer times. Android 5.0, we got Job Scheduler, and that along with battery stats for getting a better picture of exactly how evil we are. Android 5.1, there was the undocumented change where repeating alarms can have a period of no less than 1 minute. A change that still is undocumented, and none of that apparently was deemed sufficient. And so in Android 6.0, the gloves come off. You're welcome to request background processing. Whether you get it depends on environmental conditions. There is now doze mode. You can think of this as the nightstand scenario. User takes their phone out, plops it on their nightstand so they have ready access to it, but they don't put it on a charger. It's just sitting there. For the first hour, life's fine. Everything's normal. But then we're going to go into doze mode, and while we are in doze mode, background processing is severely curtailed. You're only going to be able to get control sporadically. You'll be blocked from processing for about an hour, then you'll get a little window, and then 2 hours, and then a little window, and then 4 hours, and then a little window, and then 6 hours, and then a little window, and so forth, to try to stretch out the battery life. The first question is, does it affect services? It affects everything. The question is, if you're playing music, and that would it affect that if it doesn't have these criteria? Specifically in the case of a music player, one would think that there is a way to make that work. And it may be that it's tied to, the Android detects that there's audio playback going on, and that may be tied in there. But as we'll talk about in a bit, like the partial wake clock that you might ordinarily be using is unaffected by doze mode, will block those as well. And that full wake clock, screen on, video players, that definitely stops doze mode. And so we don't have to worry about, the user's got their tablet set on a stand somewhere and they're watching the movie, and that it's not like the user's got to make sure that they jostle the thing once an hour, and that in order to prevent it from going into doze mode. But the audio is an interesting one. There's obviously some scenarios where you might want to say that it's going to sit there for an hour plus, but I haven't found how that would stay going, and I haven't specifically tried setting up an audio player, seeing if it runs past the hour and so don't know all that. Question over here. We'll get to exactly what stopped here in just a moment, so hold that thought. So we have doze mode. This affects every app. There is also app standby, which is an app-specific state. If the user has not been in your user interface recently, they haven't been in one of your activities, you don't have a notification going, such as for a foreground service, for audio playback or something like that, and the device is not charging, Android is going to say, all right, we're going to move this app into a standby mode. Yeah, you got the sticky service and all that stuff, and that ordinarily we will just restart that one after your process gets terminated, but you're still going to wind up in what is functionally reminiscent of the doze mode state, that you're not going to actually be able to keep the CPU going, and you're not going to cause the CPU to wake up and go do work on a periodic basis. And so what gets blocked is the stuff that causes the CPU to power back on and stay on for any sort of time. Your wake-up alarms aren't going to work. Your job schedulers events, those jobs aren't going to run. Sync manager ain't going to sync. If you have an outstanding partial wake clock, and that's going to be ignored, and that CPU will still go into a sleep state. And again, full wake clocks, where it's a screen on, so like Android keep screen on equal true in your layout file or whatever, and that does block doze mode, and presumably blocks app standby since you're in the foreground, but all these other things that would cause the device to wake up or to stay awake get stopped in doze mode, get stopped with app standby. You'll get the windows, you'll get opportunities. With app standby, maybe get control once a day with a little bit of network access in order to be able to go do something. For a lot of apps, this isn't going to be a huge deal. Even for some apps where the developers hear about this and go, it may not be a huge deal because you've been doing stuff in the background with an eye towards making sure the data is fresh for when the user does pick the phone up off the nightstand and go take a look at it. As soon as the user picks up the phone off the nightstand, that accelerometer reading is going to cause the device to exit doze mode, and pending work is going to be allowed to go. It may get a little crowded at that point in time. There's going to be a lot of contention on the device, and so you may wind up having some stale data simply because you didn't get your time slice fast enough, and therefore, before the user went in and tried looking at your app. But on the whole, it's not that bad. And a lot of users, and that they're not necessarily going to, pick up the phone off the nightstand and immediately power it on and look at it. They're going to pick it up off the nightstand and they're going to put it into their jeans pocket, or they're going to put it into their backpack or their purse, or juggle it in 2 chainsaws, or whatever it is they normally do in the morning. And there's going to be a window of time there when the device is moving. You won't be in doze mode, and therefore you'll have a shot of being able to get your data updated. Question here. The question is, what about an alarm app? And the answer is, I don't know. I have not found a way around these limitations, other than perhaps there's the set alarm clock methods available on Alarm Manager which basically are designed for publicly visible alarm sorts of events, and so alarm clock apps may be able to leverage that. That might be immune to this sort of stuff, but regular Alarm Manager stuff is not. The scenario that I usually will use is an email client, and that where the email app, you've got triggers set up where, okay, when you get the email coming in from the web server saying, from your monitoring agent saying the server's down, you'd kind of like it to play, the warning klaxon sound as a ringtone. That implies that you are continuously checking for email while that phone is on the nightstand in order to see, have we gotten an email from the monitoring agent? Do we need to play the ringtone? Don't have an answer for how you're supposed to work around that. And in part, that's because there may not be any, because Android developers, y'all don't take no for an answer. If there's a workaround, everybody will go use the workaround. We as users might say it's perfectly reasonable for the alarm clock app or the email client to be able to get access in the background periodically, but there's no good reason why XYZ game should be getting control in the background periodically to refresh its ad inventory. There's no reason why they should be doing that when I'm not using the device. But too many Android developers, they think they're the special snowflake and that they get to use it all anyway. Or, the pointy-haired boss said, well, we have a requirement that it behave this way. Yeah. And so I don't have a great answer for that. We'll talk about some of the workarounds here in just a moment. There was a question here first. Question about user opting in. We'll get to that in just a moment. Question here, same question. Okay, so to avoid app standby, where it's because the user has not been in your UI recently, you get moved to a dozing style state, there is a whitelist. The user can go into the settings app to that same basic area, and that where there is this battery optimization entry, listed in here will be the apps that are not optimized, which is Android speak for works normally. You can toggle that to the all apps list, find an app that you want to go in here and say, all right, I want to not optimize it, meaning I want it to work normally, in which case then it will not be affected by app standby. But the user's got to figure out how to get here, and that there is no good way to get the user here. It's like you have to click the magic gear icon and then hope that Samsung or whatever doesn't change the icon. For app standby, if you have a notification, such as you've got a foreground service going, and so therefore you've got icon in the status bar, and that is sufficient to keep you out of app standby. And so it may be that you say, okay, either we always have that, or there's maybe a preference where we say, okay, if the user wants to, in our app, they can say, yes, I want to make sure that this stuff is more likely to keep going. Let's go in and show that notification. Alarm Manager has a couple of new methods. Set and allow while idle, and set exact and allow while idle work like set and set exact, saying it's a one-shot alarm. Here's the time I want the event to occur. Here's the pending intent to invoke at that point in time. The and allow while idle means, from an app standby standpoint, it is supposed to allow you to keep going. Whether or not those methods affect doze mode is up for debate. The documentation says that they affect doze mode as well. They will allow you to get control at least once every 15 minutes. Diane Hackborn, one of the core Android engineers, disagrees. My testing disagrees. I cannot get these methods to get me out of doze mode. And that they behave just the same as the regular alarm manager methods. And so mysteries abound, and that is the story of my life, and that's why I'm out there with the machete hacking through the underbrush trying to clear a path for everybody else. Question here. The question is, could you shake the device yourself sufficiently? My guess is that using the vibration motor, and that will probably be insufficient acceleration, and that you could say, hey, user, could you hook up like a Raspberry Pi and an Arduino kit and whatnot, and that with a hand that shakes the phone? But for that, they may as well just plug it into a charger, and that. The other magic trick is Google Cloud Messaging, because surprise, surprise, Google whitelisted themselves. And so if you're using GCM to push stuff down, that will give you a little bit of control, and that you'll get a window, even though normally the device is in an idle mode, you'll get a window where you'll be able to go in and do a smidge of work. But if you've been using something else for push, MQTT based, whatever, and you're in trouble. Backups. People wonder why I rail about backups, and that you think that backups are like motherhood and apple pie, and backups have changed with Android 6.0, and that it used to be you had to write a backup agent and do all sorts of mishigas in order to get it working. Now, pretty much they just back up the whole shooting match, and that's the default behavior. If you do not specify otherwise, they will back up everything in your internal storage and your portion of external storage to the Google Cloud, encrypted by a Google-supplied encryption key. And so really this is disaster recovery. This is aiming for the user's device met an unfortunate demise, and that they buy a new device and that they want to get their data back. But there are issues here for some apps. Regulations and whatnot, and that may say, hey, we just can't have our data magically be spirited off to XYZ location. And you're trusting in Google security. You're looking at those Google terms of service and saying, there's all these clauses about being able to give data to third parties, and how does that affect this stuff? And so therefore this automatic backup stuff is not necessarily going to be appropriate for all apps. My strong recommendation is to start by opting out. Set allow backup to be false in your application element, then talk to a lawyer. And figure out what your exposure really is here. And then choose how to proceed. Maybe the right answer is you remain opted out. And that this is an app that's holding on to medical data. We need to have a much more tightly controlled backup regimen, and that we're just going to not deal with the Google stuff. We'll have our own thing that's HIPAA compliant. Maybe you say, all right, some data will allow it to be backed up. There's a new XML metadata-based system that allows you to more readily specify these are the things that can be backed up, these are the things that should not be backed up. Maybe the answer is that you'll allow it to be backed up, but it's because you're storing the data encrypted with a user-supplied encryption key in the first place. You're using SQL Cipher for Android or something like that, saying it's going to be encrypted at rest on the device, and so yeah, Google can back up that encrypted thing, but nobody is going to be able to get at that unless they can get the encryption key away from the user, possibly involving a $5 wrench. Or you could say, hey, we don't have a problem here, and that all we're doing is storing high score data, and that for our game, there's no privacy, security issues in that here, and that they will flip allow backup to be true, and get all of the backup goodness. And so just think it through. The allow backup is true by default. If you do not opt out, you will be backed up. So again, you don't necessarily have to leave it false, but until you've got a plan, I strongly recommend it to be false, and that until you know these are the concerns, you and your team and whatnot sat down, you all nodded the heads and said, yep, this is what we're going to do going forward, and then you implement that. But until you have a chance to have those sorts of discussions with the right people, and that, opt out and then proceed from there. Another little feature, and that some Android devices have removable storage, micro SD cards and the like, and that the Android 6.0 allows the users to adopt those, basically saying that we're going to extend internal storage, in effect, onto that removable card. The card gets reformatted into an encrypted partition, and apps can be moved there. This is reminiscent of the old apps to SD stuff that we used to use in like Android 2.3 that largely went obsolete when internal and external storage simply became separate directories on the same partition, the actual onboard flash of the phone or tablet. But with this adoptable removable storage, the user can expand that internal storage, and now apps can possibly get moved out to that removable media. But from the standpoint of our apps, removable media has an interesting property. It's removable. And if our app is installed on the removable card and the user ejects that card, Android can deal with that in general, except for a bunch of things that our app might be trying to do. Like we've got an app widget, and we're trying to get control, every half an hour to update the app widget, and that we were using Alarm Manager, any of those other background processing things, those sorts of stuff, and that as back in the Android 2.3 days, you'll want to make sure that you indicate that you're not allowed to move those apps to removable media so the stuff does not accidentally get removed. Conversely, since that's the default, you can use install location on the root manifest element to say, yes, I am willing for this app to be installed on removable media, even though I'd prefer it to be installed on removable media if there is some, and that because I've got a whole bunch of stuff in this app, I want to make sure that stays out of the onboard flash and not clutter up that space. So a piece of older Android tech, the notion of the install location that a lot of developers either never tuned into or forgot about, and that over the past few years is becoming much more relevant again. Now, if your app has activities with intent filters that you advertise support for certain URL patterns, say, for example, Twitter app saying that one of their activities supports twitter.com URLs, classically, what would happen is if some app triggered an action view intent for that URL, such as, they received a text message with a link and that to twitter.com in it, and the user tapped on that link, they get the chooser. Do you want to launch this in the browser, or do you want to launch this in Twitter? Maybe there's several browsers, and that depending upon what the user all has installed. But a lot of browsers would skip that. They see the HTTP URL and they say, aha, I know how to do HTTP URLs. I'm just going to handle this internally. And so Chrome, Firefox won't bother with an action view intent. You click the twitter.com link, it's just going to stay straight within the browser. But with Android 6, you can augment your intent filter to say that you support app links. App links allow you to tell Android, yes, this website and this app are closely coupled. You do that by first finding the right edition of your IDE. You do that by having this auto-verify equal true attribute on one of your intent filters of your activity, the one that in particular has your data element saying what URLs you're supporting. In my case, it's anything in the commonsware.com domain. There's also then going to be a JSON file that you can then put at that domain in a well-known directory. Have an assetlinks.json file that provides the package name, application ID of your app, and the SHA-256 fingerprint of your signing key. For your, in this case, happens to be my debug key, but usually this would be your production key. You can get that from KeyTool, and that it can give you that hash. So you create this file, fill in this JSON, upload it to your server, and then tell Android, hey, please verify me. And then Android, when it installs the app, assuming that there's internet connection at that point, it's going to go look for that file. And if it finds it, then when the action view intent for, in this case, a commonsware.com URL pops up, we bypass the chooser. And that it goes straight to that particular activity. This does not affect browsers who don't do action view intents and keep it all within themselves anyway, but for more classic scenarios, you can skip the chooser and therefore say that it's going to go straight to the app. The user's got the ability in settings to change that behavior. Maybe they have the Twitter app installed, but they prefer to use TweetDeck or another Twitter client as their day-to-day thing. And that they can go in there and change the behavior, but the default will be that it's going to go in and it's going to bypass that chooser. If you support action send, you can augment the chooser. Normally with action send, the user gets a list of a bunch of activities in apps that can support whatever that MIME type is that's trying to be sent or shared. But you can go in and have some additional metadata inside of your app. You can say on your action send activity, hey, I have a chooser target service, where that service is going to be called with onGetChooserTargets at the point in time when the user is triggering something that's got an action send intent that matches your activity. You're going to then be able to go in and augment what shows up in that chooser with what are known as direct share targets. The idea of the direct share target is it's not only saying go to this activity, but here's some context that the user can choose from. I don't just say I want to share with one of my contacts, I want to share with Jane. Don't say I just want to put this in Dropbox under a certain folder or tag. It's this tag where you, the implementer of the Contacts app or the implementer of Dropbox or whatever, you can suggest certain tags or certain contacts or whatever that the user frequently works with to make it a little bit easier for them, a more streamlined flow. They can just click on the entry for the contextual operation. They don't have to both start your activity and then go through your own UI to go pick the context themselves. So you create a chooser target service, on get chooser targets, you'll return a list of the things to be added to that chooser. You don't actually wind up creating pending intents. You'll use a component name and a bundle, which will eventually create a pending intent under the covers for you. And those are going to be tied to captions and icons that you supply that will be used to populate the actual chooser itself. Google's been trying to get people off of Apache HTTP client for a few years now. And in Android 5.1, they deprecated the API, and in Android 6.0, it's gone. It's not in the Android SDK anymore. With apologies to the Pythons, this is an X API. There is a little Gradle snippet you can put in your build.gradle file to say, oh yeah, please give me that back. But you're better off starting to make the move to something else. If you really like HTTP client, Apache's got their own independent packaging of it as a jar that you can use. You can go back to HTTP URL connection, which is a perfectly cromulent API, or you can use something more modern, and that OK HTTP or whatever, and that you have a cleaner API, more functionality like HTTP2 and speedy support and so forth, but you really want to be working on getting off of the official Apache HTTP client that we've had in Android since 1.0. Now, at this point in these presentations, I'm told that there's supposed to be the one more thing, and so I got one more thing for you. To reduce competition, that with mobile devices against Android Wear, and that they have deprecated analog clock. So those are the sorts of things that you should be thinking about, so that when Android 6.0 ships here, possibly in just a few weeks, and that you have at least some preliminary stuff set up and that you know what the behavior of your app is going to be with respect to the user revoking some of those permissions. You opted out of the backups until you've had the right discussions and so forth. But you're going to then, these are the sorts of things you're going to be needing to deal with to be able to be a first-class citizen in the Android 6.0 realm. Again, there will be a code lab starting shortly in the adjacent room. Any last questions?
You might note for those that don't know, you can publish Android stuff right now.
Oh yeah, I mean you can.
So you may want to try let your alpha users know about it.
Yeah, I mean, there's nothing stopping you, since Android 6.0 SDK is final, and that there's nothing stopping you from going in and shipping that stuff, as opposed to the M developer preview where they tried to make it difficult. So you're welcome to get this stuff into the Play Store now so that you are ready, the key is making sure that you are ready by the time Android 6 ships for real. Okay, I thank you all for attending, enjoy the rest of the conference. Thank you.